current problem that we have chosen is about plastic waste.
Plastics is any synthetic or semi-synthetic materials that made up from organic polymers, but most of the industrial plastics are made up from petrochemicals. Plastic has been widely used in many industries in our world and reached worldwide production that has been one of a great concern due to its time of degradation that can pollute our environment. Plastic has this one properties which is plasticity that defined as ability to deform without breaking. There are 7 types of plastic, which is polyethylene terephthalate, high-density polyethylene, polyvinyl chloride, low-density polyethylene, polypropylene, polystyrene and styrofoam, and miscellaneous plastic which includes nylon, polycarbonate and others. Normally, plastic items take 1,000 years to decompose, but it differs due to each content of plastic in each item. Scientists try to solve this plastic nightmare by creating bacteria that can eat or digest plastic waste, but still much more need to be done. So, we found a problem and we had proposed a solution to solve it. So, let's see the problem.
Next, we move to the problem statement. Every disposable straw, food container, bottle and plastic bag we use, we have added up to trash and it is about 9 billion of it and still counting. Microplastic now appear in agriculture soil, fish and beer will affect the growth, reproduction and survival of aquatic creatures. The main problem of the plastic waste is the rate of production over space rate of decomposition. However, we can save our environment clean by modification of gene. Idunella saccharensis was introduced in this problem. PETase is an enzyme that resistant to microbial degradation and very stable material. It used as energy source. After we know what type of gene we use, we propose the gene which is Idunella saccharensis into the E. coli. The E. coli with faster growth rate will increase rate of decomposition. Then the E. coli will digest and eat the plastic waste.
The solution that we can use to overcome this problem is we have discovered the mutant enzyme, which is PETase, from Idunella saccharensis. It helps to degrade and assimilates PET into the simplest compound. PETase enzyme broke down PET into the compound MHET, which synthesized by the esterification of terephthalic acid and ethylene oxide. For the further process, it helps to broken down and produce carbon and water. So it can be concluded that it helps to save our planet compared with chemical process because PET degradation using microorganisms and enzymes which consume less energy and more environmental friendly option to Earth.
The procedure that we are going to propose is to apply the techniques of genetic engineering, which is gene cloning. Scientists have identified the genes responsible to produce PETase, which is ISF64831, and also SF60224, responsible for enzyme NHETase. Hence, we're going to firstly isolate the desired genes for PETase and MHETase from Idunella saccharensis bacterium. Then, the EcoR1 restriction enzyme will be used to cut both the genes and cloning vector to produce complementary ends, followed by insertion of genes into the plasmid. Thirdly, the recombinant plasmid will undergo transformation, and the fast-growing E. coli host cell will take up the inserts. Lastly, the clone that contains inserts will be selected using suitable method, and finally, the transformant with inserts will be cultured to produce the enzyme that we want. With higher production rate of enzyme, we are hoping that this can help to increase the rate of plastic degradation, specifically for PET, which is polyethylene terephthalate. Hence, the vast amount of plastic waste could be reduced, saving the environment. Thank you.